Hi everyone, this is John Keaney, student ID 18328855, and today I'll just be making my project methods presentation on the research paper I wrote last year, which was an overview of the future of e-voting systems. So why are we interested in this? It's pretty simple. For democratic countries, voting is absolutely critical. In general, we see that the more turnout a country has for its voting, the more advanced it's considered to be. So Ireland is pretty good. We have a voting turnout of 60%. It could be better. Denmark, for example, has a voting turnout of 80%. So we're in the technology age now. So with more advanced technology, why not try electronic voting? Well, in order to do that, we need the cornerstones of fair election, and we need these to be guaranteed. So anonymity, that's that your vote can't be traced back to you. Transparency, so that's that you can verify your own vote. And then privacy, which is that no one is snooping on you while you make your vote. So just some history about e-voting. Electronic voting systems really have only been used on trials and never at a large scale. But e-voting machines have been used, so that's the actual physical machine that performs the voting, like with a paper ballot. Ireland is infamously known for spending quite a lot of money, €54 million on e-voting machines. And it's also known for this because they were considered a disaster and were sold for scrap metal for 70,000 because there was a compromise at the physical level. But we did learn a couple of lessons from this, and that's for e-voting we need two important features: end-to-end voter verifiability and something called decentralized voting. So end-to-end is just is the transparency part. You can check to guarantee that your vote has been cast correctly. And then decentralized voting is just so that you have multiple copies of the vote. So if the two copies are different, then you know something is wrong. So is there any technology that implements these features? And there is. You might have heard of it. It's called blockchain. So an extremely simplified definition of blockchain is just that it's a sequence of blocks. Each block contains data, and it's very secure and impenetrable. So what makes blockchain so secure are two things. First of all is its hashes. So every time a block gets changed, the hash changes. So if your hash is different from the previous block, then you know a compromise has happened. And because of something called proof of work, it prevents too many blocks from changing at a time. But the other thing that makes it so secure is something very democratic called a public ledger. Everyone has a copy of the history of the blockchain, and they have to vote at least 51% to agree on adding a new block and verifying it. And this is all done automatically, of course. So that's what makes it so secure. And with that information, are there anyone who's tried to use blockchain for a voting system? There are. The two best ones I found is first a Zcash based voting system. This one is very secure at almost every level. There's a security check going on. It's very private. As soon as you register, from then on, no one will ever be able to trace back your vote. But the issue with this one is that it's a little bit more costly compared to other ones. Zcash uses that proof of work, so it takes 10 minutes for each block to be added, and this means you could be waiting a day or two to even perform the count for an election. It's also a little bit more costly because of that wait time. So there's another one, another voting system though we can consider, and that's an Ethereum-based blockchain voting system. This one fixes the issues with Zcash. It's more scalable and it's not as costly. But the issue with this one is that it uses smart contracts, which are unfortunately a little bit more confusing, and might not be good to push that on the average voter. So looking at our results table here, we can see that pretty much in almost every factor, blockchain voting blows the other voting out of the water. But there is one critical issue with blockchain-based voting, and that's security. So just like with the original e-voting machines that we spent €54 million on, there's no guarantee that the computer that you're using to perform the vote on is secure. So if it's not secure at the physical level, we can't use it. So only when physical e-voting is secure will we be able to use blockchain voting. So just want to say thanks to Dr. Hitesh Tiwari, who was my advanced telecommunications lecturer last year. And these are the references I used for creating this paper and presentation. So if you have any questions, just email me, keaneyjoe@tct.e. Thanks for watching.